Hello, my name's Darren Holmes, and today we're going to be using the Primer Trainer to examine lesson number 5, 8-bit subtraction. In lesson number 5, 8-bit subtraction, we have one new instruction. It's the sub-C command with the opcode of 91. And it says the C register is subtracted from the A register with the result being stored in the A register. The Z, S, P, CY, and AC flags are affected. I just want to refer you to page 773 of your textbook. You can see they have the sub command in there, subtract register or memory from accumulator. The opcode is SUB, and it's 1 byte, 1 machine cycle, and 4 T states. Now, depending on the register that we're going to be using, it has a different hex code. So we're using the sub C, and the code is 91. Under description, it says the contents of the register or the memory location specified by the operand are subtracted from the contents of the accumulator, and the results are placed in the accumulator. The contents of the source are not altered. Under flags, it says all flags are affected to reflect the result of the subtraction, and they give you an example underneath. So I just want to refer you to page 193 of your textbook, or section 623. Talks about subtraction. The 8085 performs subtraction by using the method of 2's complement. Subtraction can be performed by using either the instruction SUB that we're using to subtract the contents of the source register, or the instruction SUI to subtract an 8-bit number from the contents of the accumulator. It says in either case, the accumulator contents are regarded as the minuend, or the number from which to subtract. And then it goes on to tell you the 8085 performs the following steps internally to execute the instruction SUB. So it converts the subtrand, the number to be subtracted, into its 1's complement, and then it adds 1 to the 1's complement to obtain 2's complement of the subtractand, and then it adds 2's complement to the minuend, the contents of the accumulator, and step 4, it complements the carry flag. And just below that, it says these steps are illustrated in the following example. So I just want to remind you that we covered all those topics in your digital course, and you're more than welcome to go back and review your Shams Outline Digital Principles 3rd edition textbook. So page 175, or section 8-3, talks about binary subtraction that you may wish to review. And 2's complement was covered on page 10, or section 1-4. And figure 1-11 shows us the 2's complement representation of positive and negative numbers. Just wanted you to note here, in A part of figure 111, the most significant bit is the sign bit. So looking at the lesson, it says this program will subtract the C register from the B register and store the result in the accumulator. This is done by copying the value of B into A and then subtracting C from A. The result will appear in the A register. So we've got our assembly language listing. You can see we start FF01. We're going to move B into A. We're going to subtract C, and then we're going to stop the program. So here you can see we have the opcode 7891 and FF. So under part 1 of the procedure, to test the sub-C instruction, we're to load the program into memory and move the program counter to FF01. Load the BC register pair with 9 and 6, which is the same as loading B with 9 and C with 6, and then run the program. When the program stops at FF03, we're to notice that the A register is now 3, which I believe is what 9 minus 6 should equal. And then we're going to convert the flag register to binary to see that the carry flag is indeed 0. So we're going to turn on our primer trainer, and then we're going to load our program. So at FF01, we put in 7, 8, enter, then 9, 1, enter, and then FF, enter. Then we're going to go backwards, decrementing to make sure the program is entered into our primer trainer. Now we're to load 9, 6 in the BC register pair, so we press function B, and we enter the number 0, 9, 0, 6. Remember to press enter. And then we're going to run our program, function run. We're going to check the AF register pair, function AF, and you'll see the answer is 0, 3, and the flag register is 1, 4. So let's take a look at what has happened here. We loaded B with the number 0, 9. We loaded C with the number 0, 6. We ran our program. The accumulator ended up with the answer 0, 3, which is 9 minus 6, and the carry bit is 0, as we had expected it to be. Internally, what happens is the microprocessor takes C, which is 0, 6, which is 0, 0, 0, 0, 0, 1, 1, 0, and it does the ones complement of that. So we end up with 1, 1, 1, 1, 1, 0, 0, 1. And then it adds 1 to that number to come up with the 2's complement. So that's 1, 1, 1, 1, 1, 0, 1, 0. That's the 2's complement of the number 6. B contains the number 9, and that was moved into the A register. So 9 is 0, 0, 0, 0, 1, 0, 0, 1. So we add that to the 2's complement of the number 6. So 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 1 is 0, carry the 1. So that's your auxiliary carry bit. So the auxiliary carry gets set. Then 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, and our carry bit gets set. Now keep in mind, when we do the subtraction command, the carry bit is then complemented, so our carry flag ends up being 0. The parity bit, you'll notice there's an even number of 1s in our answer, so our parity bit is set. Our 0 bit is reset because the answer is not 0, and the sign bit is indeed 0. So our flag register ends up being the number 0001, which is 1, and 0100, which is 4. So that's the 1, 4 we saw in the AF register pair. Now in the second part of the procedure, we're going to press the reset button and load B with 1F and C with 3D and rerun the program. Now we're going to see in this case the A register is E2 and the carry flag is 1. It says in every subtraction the carry flag is set if the number in the A register is smaller than the value being subtracted from. In this case the A register was 1F and 3D was subtracted from it. In this case, the carry flag could more appropriately be referred to as the borrow flag when the flag value is the result of a subtraction. So having pressed the reset button, we're now going to load the BC register pair, function BC, and we're to load in 1F and 3D. And remember to press enter to enter it into the BC register pair. We're now going to press function run, and when it stops we're going to press function AF, and we can see that the answer in the A register is E2. And looking at the flag register, we're going to have to decode that. So let's take a look at what's happened here. We've loaded the B register with 1F, loaded the C register with 3D, ran our program. The result in the accumulator is E2, and the carry bit is actually set to 1, which is actually a borrow now. So here's what's happened internally with the ALU. The C register contents 3D is 0011, 1101. So internally they've taken the 1's complement of 3D, and that's 1100, 0010. Then they add 1 to that number to come up with the 2's complement. So that ends up being 1100, 0011. So this number is then added to the accumulator, which is 1F, which is 0001, 1111. So looking at the math here, 1 plus 1 is 0, carry the 1. 1 plus 1 plus 1 is 1, carry the 1. 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. So that's our auxiliary carry bit being set. Then 1 plus 1 is 0, carry the 1. So 1 plus 0 ends up being 1. 1 plus 0 ends up being 1. And 1 plus 0 ends up being 1. So the sign bit gets set. The carry bit is 0. And we know that when we do a subtraction, it gets complemented. So the carry bit ends up being a 1. The parity bit ends up being set because we have 1, 2, 3, 4 1 bits in our accumulator. So when they're all even numbered bits in the accumulator, the parity bit gets set. So we end up with 1001, 0101 in our flag register, and 1001 is 9, and 0101 is 5. So there's a lot more to doing these lessons than just typing them into the primer trainer and pressing run and see if they work. There's a whole bunch of math that goes on behind the scenes so that we can fully understand each of our lessons. So let's review Lesson 5 using the Primer Simulator. The first thing I'm going to do is turn on my simulator. And now I need to load the code starting at FF01. I start with 7, 8, enter, 9, 1, enter, FF, enter. Now I'm going to press reset to take me back to FF01. I now have to load the BC register pair, so I press function BC, and the number to load is 0906. And I press enter, and then I press function run. Now I need to check the AF register pair for the result, so I press function AF, and you can see my result is 03, and the flag register is 14. To decode that on the simulator, I can go to View, Register Contents, and you can see in the program status word, which is the AF register pair, checking the carry bit, you can see it's 0 or reset, indicating that there was no borrow. To run procedure 2, I can press the reset button to take me back to FF01. And now I have to go to Function, BC Register Pair, and load in the number 1F3D. And press Enter, and then Function Run. Now I need to check the AF register pair again. And you can see the result is E2 in the accumulator or A register and 9.5 in the flag register. Once again, I'm going to go to View, Register Contents. And in this case, you can see the carry bit is set, indicating that a borrow has occurred. So once again, our simulator seems to be working just like our original EMAC Primer Trainer. This concludes lesson number 5. In lesson number 6, we're going to be looking at 16-bit subtraction. So remember to subscribe so you don't miss any of our lessons.